right. Hi, everybody. I think we're going to go ahead and get started. So my name's Savannah Shelnut. I'm the CCE Ag Climate Resiliency Specialist for the Hudson Valley. Katie O'Neill, who you see here, is my counterpart. She works statewide, and we work to help connect farmers and other landowners with resources to adapt to and mitigate the impacts of climate change. So today we're really excited to have Dr. Debbie Aller with us. She's a soil scientist with Cornell Soil Health, and we're gonna be watching a webinar that she did for us previously, but we really wanted to include her in this series as we're gonna have a biochar field day next month in the Hudson Valley. I'll put details about it in the chat. We wanted to have this as sort of a primer before that happens, but we didn't want to burden her with doing the same thing twice. So we have a recording we're going to play. There are going to be polls throughout, and Debbie will be here. You can put questions into the chat, and we'll get to them either throughout the presentation or at the end. She'll be here for a live Q&A. So we're really excited to have Debbie. I'm just going to let her introduce herself live really quickly, and then we're going to begin. Thanks.
Yeah, thanks so much, Savannah. And yeah, as she mentioned, Debbie Aller. I'm based in Ithaca at Cornell University. I'm an extension associate working with the New York Soil Health Program and Cornell Soil Health. And yeah, you're going to hear a recording of me today, but as Savannah mentioned, I will be here to answer any questions you have around biochar, other soil amendments, and I think organic matter and soil health generally. So feel free to shoot your questions in the Q&A or chat feature, I think, as the webinar is being played. And I'll answer those as I can. And yeah, I'll just be around for discussion at the end. So thanks for attending.
Great. All right, we're going to get started then.
So the way I'm going to move through my presentation today in about the next 40 minutes or so is the first few minutes will be just background on the carbon cycle and soil organic matter and the different pools of soil organic matter. And then I'll move into just a very brief overview of some different soil amendments that are more commonly used on farms of various different sizes and are working with different commodities. And then I'm going to spend the second half of my presentation really focusing on biochar. And for folks who have, some of the folks on this call or webinar today have seen some of this information before, but hopefully there's some new information as well that you'll find beneficial. So moving on here, just a high level overview of a very simplified version of the carbon cycle. Really showing the role of soil organic matter within the carbon cycle. Let me see if I can get this. And so you can see plants take the atmospheric carbon, use that carbon dioxide, use that as energy, and utilize that within photosynthesis to grow. As crops die, there will be various residues that input carbon into the soil. And that carbon becomes a component of soil organic matter. And then soil organic matter that can be lost in the system through erosion, decomposition, respiration back to CO2 within the atmosphere. So very simplified cycle of carbon, the carbon cycle here. But I think it's important to really differentiate, and this is something often people confuse, is the difference between soil organic matter and soil organic carbon. So just defining those to start. If folks were on the webinar 2 weeks ago by my colleague Joseph Arancilli, he may have showed some similar diagrams or similar slides. So I apologize for anything that may be repetitive here in the initial part of the presentation. But just want to emphasize what soil organic matter is and the fact that the carbon within soil organic matter is what we consider soil organic carbon. And that soil organic matter is typically about 50 to 65% carbon. What's really important to note that other than fossil fuel carbon, soil organic matter is the largest terrestrial sink of carbon in the world. So we know there's a lot of carbon within our oceans, but there's also a ton of carbon within our soils, and soil organic matter is really the largest pool other than the fossil fuel carbon, as I mentioned. And they store carbons, both organic and inorganic forms, being carbon dioxide as well. So this is just a high level overview of, once again, linking what we call kind of the green carbon cycle and the blue carbon cycle, which is within the oceans. So as I mentioned before, the original source of carbon is coming from CO2 within the atmosphere. And the inorganic carbon coming from CO2 that is fixed by plants, creating biomass, and through photosynthesis and a lot of that fresh plant material will eventually become, as it decays and decomposed and is consumed by microorganisms, will enter the soil organic matter pool. And the total amount of soil organic carbon is controlled by these inputs going into new systems and outputs being lost through decomposition or erosion. So really, what is soil organic matter? And we can view it as a high level of material that is in the soil, and it contains carbon. It's derived mainly from plant residues, these being both the above ground biomass, the litter material that may be left on the soil surface, as well as the roots. And the roots play a really critical role in contributing to soil organic matter. And we know this when we think of cover crops and keeping the soil covered year round. The remains of dead animal and micro and macrofauna and their excreta and living soil microbes. So microbial biomass, all of these enter the soil organic matter pool. And microbes themselves, we can think of fungi, actinomycetes, bacteria, and other microorganisms. They process a lot of the fresh material, and then over time it becomes and enters this soil organic matter pool. Largely, most people think of soil organic matter as three types or three pools of soil organic matter, but we know this isn't black and white. We know there's a gradient here, but you can largely think of soil organic matter as three pools. These being the living, also often referred to as the active or labile pools, then the dead, which is our slow or our more humic type pool, and then the very dead being our passive and recalcitrant pool. And mainly that very dead pool is something like biochar that we're going to talk about today. And part of this has to do with the time and the degree of degradation within the soil environment. So here are just a few pictures here of some of those three different pools of soil organic matter. And we know all three of these pools really contribute to a healthy soil and a well-functioning system that leads to greater crop yields. I think everyone here really knows and understands the importance of soil organic matter. I don't need to elaborate on that, but we know it has great impact for soil, water, and nutrient retention, and that the organic matter fraction really occupies a small portion of the overall soil volume, but it has an incredibly large impact when it comes to soil health. So here are just some images and a little bit more information on that living pool of organic matter. And this is that readily available active pool of microfauna in the soil: earthworms, nematodes, mites, springtails. And these really are the organisms that are making nutrients available that are in the soil solution available for uptake to the plants. They're helping in disease suppression and other physical soil parameter improvements. The dead pool, this is that middle pool, this is a slower pool, and these are organisms that have recently died and crop residues that might be remaining on the soil surface or incorporated into the soil that can be consumed by microorganisms and have nutrients or help with microorganisms growing as well, and then that availability to plants at different points. And so this is the pool of organic matter that microbes mineralize and make available to plants, as I mentioned. And then this very dead pool, this passive or recalcitrant pool. And this pool of soil organic matter has kind of evolved over time in a more historic view of thinking about this humus pool. A lot of questions about that, but this kind of the new train of thought is around this mineral associated organic matter and physical separation from microbes, both kind of a labile pool of organic matter and then organic matter that's stuck to soil particles as well. And we know there are a lot of benefits even within this very passive pool of organic matter that does not have necessarily readily available nutrients like some of those the more labile pools of organic matter. And so the best example we know what we're talking about today is biochar. It really fits into this stable recalcitrant pool of organic matter in the soil. So how is organic matter stored and stabilized in the soil? There are various mechanisms of how organic matter stays in the soil through chemical bonds. It can be physically protected within aggregates. There's humification as well, but this is becoming or of smaller importance than it previously was thought. And then we know materials like biochar, which are the incomplete combustion, can really stay in the soil for long periods of time and be both physically protected and chemically bound to other particles in the soil. So within agricultural systems, we all know when we look at natural systems compared to managed systems like production environments, we're disturbing the soil, we're disturbing the natural functioning, and we tend to lose organic matter in these systems. I really just like this image because it's a dramatic image of when we think from when cultivation started, well, a lot longer ago, thousands of years ago, but in more recent times, if we think about industrial agricultural production and intensive tillage of the soil, we had a decline in soil organic matter. We were turning over the soil, disturbing it, and losing that material back to carbon dioxide in the atmosphere. But we know that we can build soils back up through the addition of organic amendment. So we know soil management has a really important role in the health of our soils and their ability to function. So now I'm going to move on to soil organic matters and how we can start to improve soils again. And so what is a soil amendment? I really like to start off from the basis of what it is. To then we can think about different types of soil amendments and what they can do in different settings. So there's the definition: any material added to a soil to improve its properties. And these can be physical, chemical, or biological improvements. And the idea is that by adding a soil amendment, it will eventually improve plant growth, often obviously yields and productivity within production environments. And so various improvements there from the rooting environment to improving microbial activity and the physical structure of the soil, as well as improving water and nutrient retention. The quality of soil amendments varies, and there are both organic and inorganic amendments. The ones I'm really going to show today are organic amendments. I'm not going to spend time on inorganic amendments, but I've listed a few examples there of different types of amendments that are commonly used within agronomic systems, or let's say agricultural and horticultural systems. So to take a break from me talking, I'm going to launch a poll question just to make this a little bit more interactive. And before we move into biochar and move into a more discussion of soil amendments, here are some quick questions for everyone to answer. So hopefully I launched that and everyone can see. Jenna, if there are any issues, just please let me know.
Sounds good. It's looking good.
Okay. So we'll just give this a minute here, and then I'm just going to check the chat while everyone is responding to the poll. All right, a few responses so far. First question, have you heard of biochar? So far, people say yes. Are you making your own biochar? No. Are you using biochar on your farm? No. If not using biochar, are you interested in trying it? Yes. And then what soil amendments are you currently using on your farm? Compost and compost teas, manure, mulches, leaving crop residues on my fields. And I'm glad so far nobody has answered, I do not add organic matter to my soils, because we all know we need to be adding organic matter to our soils. It's very important. So I'm going to give it another about 10 seconds and end it there. Okay, I'm going to end it, but and just share the results with everyone. But I'm going to keep moving on. So thank you all for answering that poll. And so moving on to organic amendments or soil amendments in general, but really focusing on organic amendments. I always like to mention and I think highlight the importance of, before adding an amendment, just like before you are thinking about adding fertilizer to your soil, it's important to soil test and to know what you're working with and know what type of amendment you might need. It's different when we're thinking about organic amendments, right? And we know there's decomposition, and adding more will improve the soil environment overall. But I just want to emphasize the need for knowing what's in your soil and obtaining that information, often through soil testing. So one type of soil amendment are mulches. These are often used in maybe smaller production environments where we're leaving straw, shredded leaves, or grass clippings on the field to decompose, to protect the soil surface, and to help suppress weeds and build organic matter. And we know these have an impact on surface soil temperatures as well. So one type of soil amendment. Another one that is a similar idea to mulches, but is often utilized within slightly different cropping systems. And we've seen this more so within our perennial fruit systems, our wood chips. These can be great for helping conserve moisture, suppressing weeds, building organic matter in perennial systems, controlling weeds and other aspects there. And I apologize, the slide seems to have gotten cut off at the bottom there, but we know we have to think about not necessarily incorporating fresh wood chips to the soil right away, so we don't get nutrient immobilization. So often these are left on the surface to then decompose over longer periods of time. Another one, and this is one often used, I would say, mostly by many organic producers, more in specialty crops, although I've seen it also used in turf grass production as well, are seaweeds. Becoming more common. There's a lot of work going on now within New York State around seaweeds and the potential biostimulant effect that they have on plants. So this is just kind of an image of what fresh seaweed looks like after it's harvested, and drying it down, processing it, and then applying it to fields as well. So we know seaweeds don't have macronutrient benefits, but they do provide some micronutrients and then this biostimulant effect, as I mentioned. Compost teas are becoming more and more popular, something that could be applied as a foliar fertilizer as well as a soil amendment, and there's some evidence that they suppress pests and diseases, but people are really interested in them from enhancing and boosting the soil biology by directly adding microbial organisms to the soil. But the quality of these vary because we know they are a living system, and they are affected by moisture, affected by temperature, and other things. But these are things that are becoming more and more of interest to folks, and I've gotten a lot of questions over the years about compost teas and do they work, are they snake oil, on and on. Manure, something that's been used forever. I had read some historical documents about agriculture actually within New York City before it became a massive city, and all the horses and farms that were there, and manure being applied to fields to enhance crop production. So we know there are many different types of manure, whether it be cows, poultry, swine, horse manure, but these are an excellent source of nutrients, and integrated crop livestock systems can be a great practice for improving soil health. Lime, I think every farmer knows lime. I don't need to go into detail with this, but this is a soil amendment really to boost or alter soil pH. Typically, nitrogen fertilizers in particular have an acidifying effect on the soil. So lime is applied to neutralize this acidity and bring the pH of the soil back up. And we know this is important because it has to do directly with the availability of nutrients for plant growth. I do want to mention that obviously there's dolomitic and calcitic lime, and there are differences to those. If you need additional magnesium within your soil, you would go for a dolomite-like lime. Another one that's becoming of more interest to folks, or more growers are hearing about, and there's a lot of research going on, or I wouldn't say a lot, but there's research going on in this area right now, folks at Cornell and others, but this idea of rock minerals, specifically there's a lot of interest in basalts, and what are the long-term effects of applying pulverized silicate rocks to organic carbon within the soil, and there's a host of potential co-benefits around using rock minerals, but just realize that this there's more interest in this area. There's still a lot of research questions happening, but this is another soil amendment that is becoming available or of interest to more producers, not just in the US, but elsewhere as well. Another one that everyone knows about and folks are using are compost. This is the last amendment I'm going to mention before moving on to biochar. But compost, this is a picture at the top here of just a 3 bin composting system from kind of the fresh material of adding those carbon and nitrogen inputs to this middle bin, and then a mature or cured compost there. So another way to add a lot of organic matter to the soil, but it's important to think about the quality of compost as well, and making sure that compost is mature or finished before application. So now moving on to biochar, in the second half of my talk today, of what biochar is. I always start with that because there's a lot of confusion about what biochar is. And then I'm hoping to clarify what it can and can't do, and some new tools that are available to producers to make decisions around whether biochar is good for your farm, or it's something as, I know they're technical service providers here. Is this something that you want to recommend, or would it make sense for the farmers that you're working with? So biochar, we know it's basically a charcoal-like material. It's produced through pyrolysis, which is the burning of biomass at high temperature in no to very low oxygen conditions. And I'll differentiate that when I briefly mention production types, but I know Mike's going to talk much more about the production side of things, so I don't want to spend too much time on that. But within the pyrolysis process, we take this feedstock. This is our starting material, and this can be any organic waste material. It can be crop residues, but obviously we don't want to take crop residues if they're having other soil health benefits. This can be manure if it's dried down manure. This can be woody material from dead or dying trees that have been harvested. This can be prunings from vineyards or orchards. So it's that organic waste material through pyrolysis, and we get 3 end products. One of those products being the solid biochar, which I'm focusing on here. So as I mentioned, it's a charcoal-like material, and it looks a lot like charcoal, but it's different from charcoal because it's not a fuel. It's used for agricultural and environmental applications. Very high carbon material, and you can think of the if you look under a microscope at the biochar physical properties, it looks like a sponge. There's larger pools, pores, smaller pores, and it's got a carbon backbone to it, and that's really the structure that makes it recalcitrant or a long-lasting amendment when it's applied to the soil. Biochar has numerous potential properties. Sorry, I'm getting ahead of myself here, getting excited talking about biochar. Numerous potential benefits within agricultural and environmental systems. And I say potential because I will clarify down there that we're thinking about the correct biochar to the correct soil type to have a particular impact. But here's a wide range of potential impacts it can have on the environment. And these aren't just the only ones. And I do want to say there are many uses of biochar beyond agricultural applications, to actually using them in building materials like drywalls, where we can make building materials carbon negative and carbon sinks. Biochar is not a new idea. Many folks here have probably heard it or read about the terra preta soils in the Amazon, which is really, I think, where the modern idea of biochar came about. This is an ancient technology, and biochar is this really new take on an ancient practice where we've seen high fertility soils in parts of the world that are naturally highly weathered and lower producing soils because they have higher rates of decomposition, and they're not able to store as well. They are able to store carbon, but they're highly weathered, and they might be more acidic. But we know through organic additions and long-term organic matter additions, we can build fertility within these soils, as you can see in the image here. And we know there's soils like this in the US, particularly the Midwest, and that largely has to do with repeated prairie fires in places like Iowa, where we know a lot of the carbon in those soils is actually it's like a charcoal recalcitrant form of carbon. So biochar production, and I know Mike's going to talk about this and the field day is going to show this, but I like to have this slide that biochar can be produced and is being made at many different scales, all the way from these integrated bioenergy systems, which are really geared towards producing gases and oils used for other applications, all the way down to stoves that double as cook stoves in smallholder farmer areas or within subsistence agriculture. So no, there's a wide range of production technologies, and these ones on the lower end are where we might get some oxygen into the system. It's hard to completely eliminate that there. And there's production happening on farms, and there's ways that it can be produced with organic waste materials directly on different operations. Beyond there are many climate benefits, and that's one of the key things around biochar and a lot of interest in biochar, because it can not only aid in climate mitigation, but adaptation as well, and that it's a long-term storage of carbon in the soils. There's work that's been happening by researchers around the world in thinking about the potential of different biochars to help in reducing current anthropogenic carbon dioxide levels. And one of its main benefits, no matter where we are applying biochar, is that it builds carbon in our soils and it sequesters carbon. Some more work, and this has been of interest to folks within New York State as well, but this figure on the right here is actually some recent work coming from California and looking at applying biochar to composted dairy manure Obviously, the dairy industry is huge in New York State as well. So there's more interest in finding ways to reduce methane, and a potent greenhouse gas from the dairy sector. So there's evidence that really biochar can play a role in reducing methane emissions from dairy facilities. So this image is getting at the stability of biochar within the soil environment, and the fact that it's part of the dead or this recalcitrant pool of soil organic matter, and it degrades over hundreds of thousands of years, and it degrades on much longer time scales compared to the comparable uncharred organic matter. But we also know that the stability of biochars vary depending on that feedstock I mentioned, whether it's made from grass clippings or manure or a woody feedstock, as well as the production conditions as well. So this image on the left, for those who haven't seen it before, are this degradation rate over a short-term, relatively short-term experiment, how much of that biochar remains in the soil when it's coming from different feedstock materials. So you can see there is some variability there, as well as the production conditions, thinking about pyrolysis temperature. We know that the higher the pyrolysis temperature, the greater the fraction of biochar that will persist in the soil for more than 100 years. The H to C, or hydrogen to carbon ratio, is typically the variable, the parameter used to indicate stability of biochar in the soil. And the lower that H to C ratio is, the greater their stability in the soil. And we know that has a direct connection to the pyrolysis temperature that's used to make the biochar. But this diversity, this feedstock diversity, this production diversity leads to different impacts that are soil, crop, biochar, environment, and management dependent. So this is the S by C by B by E by M impacts. And we also know biochars, because they are organic matter, even though they are recalcitrant, their properties change over time as well. They're physically degraded, chemically degraded, and biologically. So there is some variability over time as well, even though they are largely stable. And so we have an incredible technical understanding of biochar, and this is shown by this figure here, which is from a recent publication that's showing there's really, over the last decade, been close to 30,000 peer-reviewed publications that talk about biochar or have a study around biochar. But we know there's this complexity and this site specificity associated with biochar based on some of those parameters I just mentioned. So we're not seeing widespread adoption of biochar yet, because there's still this uncertainty, and producers don't want to introduce more risk into an already inherently risky business. So what's important when thinking about using biochar, or working with someone who's interested in biochar, is talking about what is the problem you're trying to solve. What is the limiting factor within your production system, or the resource concern that you're having on your farm? We know biochars are not one size fits all, and we don't want to just spend money and use biochar to use it. We're thinking about what is the reason, identifying our goals, and figuring out what's the right biochar for our right soil. Are we wanting just to increase carbon in our soils? Are we looking to increase water and nutrient retention, infiltration, structure? We know biochar interacts differently and has a different effect in clayier soils versus sandier soils, which I'm going to mention in a little bit. But just something important to think about, that what is the issue that you might be having on your farm or a farmer you're working with. And this idea and thinking about Why are we using biochar? We can really learn a lot, I think, from the 4 R's of nutrient stewardship. And this is not my idea here. This is something, there's a paper on this, but taking a similar idea of the 4 R's and applying them as the 3 R's to making biochar decisions. So learning a lot from all the work that's been happening around nutrient management and thinking about that in the context of biochar applications. Thinking about the right source of biochar, so that right starting material, what's the feedstock? Do we have a woody, are woody materials more readily available in New York, in the Northeast, compared to oat hulls or something like that? What's the right rate for our soil type and the resource concern we have? The right place. Are we working within perennial systems or within annual cropping systems? Where we apply that biochar, how deep we apply that biochar are all really important. So this is some way to think about biochar applications and thinking about it in the context of nutrient management as well. We know overall that biochar improves soil health and can be an important part of any producer's soil health management toolbox. It is another amendment that is available for producers to use, and we know generally it has significant positive impacts on the soil environment. So this slide is just summarizing some of these benefits. This slide here is, and I've showed this before in presentations, that across thousands of studies around the globe, that biochar generally positively impacts numerous agronomic parameters. So on the left here, we can see the parameter of interest, whether it be photosynthetic rate, water use efficiency, crop yields. And when we look to the right of 0, that's a positive impact, and to the left, a negative impact. But overall, for something like crop yield, we see around a 10% impact, increase in crop yields when we're applying the right biochar in the right soil type. So overall, there are positive benefits to a wide range of parameters, not just water retention or for carbon sequestration, but microbial cycling, nutrient retention, and general for soil health. One thing I did want to highlight, and this was some relatively recent work that came out of some modeling by researchers down in Texas at Rice University, and looking at the potential of a soil water holding capacity to be improved by biochar. And I just want to highlight that there are opportunities for biochar to improve water retention, water holding capacity in soils within New York. But as we see here, and I'm going to mention a little bit later, is that the benefits are going to be the highest in sandier soils, in the sandier parts of our state. So actually in regions of the Hudson Valley and Long Island are likely to see more benefits in terms of soil water with biochar application than parts of, let's say, the Lake Ontario region and the southern tier. I'm not going to get hung up on talking much about application rates right now. I know this is of a lot of interest to producers, but I do want to show some more of the decision support tools at the end, and I have a lot in my presentation and not enough time to talk about it at all. There are different application rates depending on the soil type, and this decision support tool that I'm going to mention will assist with this moving forward. But the one thing I do want to highlight in this context is that more is not necessarily better when we're applying biochar. We're not thinking about excessive 20, 30 tons per acre rates. We're thinking smaller application rates, potentially repeated application rates, depending on the cropping system we're working in. But it is important to mention that biochars really need to be inoculated, that starting that freshly produced biochar is the carrier. It's the backbone. It's a relatively inert material. and mixing it with some high value nutrient material, whether that be a manure or a compost, is really important. There is evidence that if you're applying biochar just as a freshly produced material, it's going to suck up the nutrients within the soil, leading to immobilization and potentially having a negative effect on crop yields. So thinking about applying a small amount of biochar with a nutrient-rich material, I think this is very important. And this is more, if you look in the literature, this is more where we see the greatest benefits of biochar is when they're mixed. And there's a synergistic effect of kind of that quick release nutrient availability coming from manure and compost, and then that more recalcitrant carbon structure with the biochar. I want to launch a second poll question here before we move on. Let's see. And before I talk about barriers to adoption of biochar, some points, I want to see what everyone thinks. In the context that you work in, what barriers do you see to adopting biochar currently, whether you're a farmer or you're working with farmers? And Jenna, I think I have like a few minutes left.
Yes, yeah, a couple minutes, and then if you want to take questions after your presentation or at the very end, it's up to you.
Okay, I'm going to go through these last slides quickly, but just highlight them. Okay. Uncertainty, cost, availability. So it sounds like there's more technical assistance. People are aware of it now. There's obviously a lot of research that's been done. Need for trials. Awesome, great. I'm going to end this and keep moving. Or I can share results quickly. But okay. So to move on, we know that producers in New York State are using this, and we know producers around the country are using this, but it still remains on higher value specialty crops. These are some of the areas that biochar that I know of is being used in New York State. It is also used in field crops, but to a much smaller extent, and we need more on-farm trials within the state under our production conditions to really see, does it have value? And as some of you pointed out, one of the limiting factors and barriers to adoption of biochar is both its availability and its cost. It is more expensive than other soil amendments, and we know that. And as the industry grows and it becomes more available on the East Coast, this cost is likely to drop, and there are many low-cost opportunities for producers to make biochar themselves. And you get obviously a lot of long-term benefits from using biochar, not just these annual nutrient availability you might get from compost and manures like that. And a lot of the cost around biochar currently has to do with transportation and it being moved across the country. But I do want to highlight this. I'm not going to get hung up on it because I know I'm already over time, but I do want to mention a new conservation practice standard available by the NRCS, and I'm going to refer everyone to go listen to an excellent webinar that was just organized by the United States Biochar Initiative and the NRCS that talks about the nitty-gritty of this new financial assistance program. Field applications of biochar, I'm happy to talk with folks later on about different field application methods to different cropping systems and different methods of incorporation, whether you are a no-till producer or not. I'm moving through this slide quickly, but where do we apply biochar and where do we think about applying biochar? And we know from on-farm work, from other research, that our sandier soils are more degraded soils, where we're looking to build organic matter. where we might have acidity issues, these are likely the spots where we're going to see a positive response in yield from biochar applications. So this it may be what it looks like within New York State, and I've showed this map before, and I want to tie this map that was really produced by one of my colleagues, Professor Dugohaki, who was at the University of Illinois but is not anymore, and the work he did that really led to then the integration of the creation of this dynamic soil properties response to biochar tool within Web Soil Survey. So this is something you can do when you're sitting at home over the winter, whenever, and you can look at your fields and get some idea of, given my soil types, is there a potential benefit from applying biochar within my to my fields? Regardless of cropping system, this is really tied into the soil survey data and information, and it gives you a rating of excellent to unsuited for the potential increase in crop growth through biochar applications. There's some assumptions here within that tool, and it's based on a single application rate in this single corn stover plus manure biochar type. But it's a really excellent tool that gives producers some insight into, should I even be thinking about biochar within my system? Will it make sense? Are my soils already productive, or do I not have the right soil type for getting a return on investment from utilizing biochar? So I encourage everyone to go into Web Soil Survey, find this tool under the Soil Health tab, and look at your fields or the fields of producers you're working with. And the last thing I do want to mention is a biochar decision support tool that is available. Some of you just mentioned in that little poll that you're looking for some decision support tools. And this is a tool that was started as the Pacific Northwest Biochar Atlas. So it was developed by a really great soil microbiologist, Kristen Tripp, and other researchers for Pacific Northwest biochar producers and users. And so the biochars that are within this tool right now are only for the Pacific Northwest region, but there's work ongoing right now to expand this to a national biochar decision support tool, but it's still very useful. And I encourage everyone to go to this website. And once again, you can mess around with your soil types. You can import your soil types. You can import biochar properties, and it will help make decisions. Is this the right biochar for the right soil type? And does it make sense economically as well? So this is available. And if you're looking for a tool like this, please go and play around with that. And
Okay, we're gonna go ahead and end it there and resume in real time. So yeah, hope y'all enjoyed that. Debbie, I just wanna ask you if you wanna elaborate on any of these great questions that we got in the chat.
Yeah, and it's always really strange listening to yourself. And of course, things I said then, I would have probably, there's definitely a few things that are updated from what I presented even a year ago in this. And I think I did answer all the open questions. But there was one I did want to mention or elaborate on for cost, which was the first question that came through. And I can't speak necessarily to the cost for actual production of this material. And I would say it varies very widely, which is what I was trying to get at. Really based on the availability of the feedstock or what feedstock you're trying to produce biochar from, the size of the equipment, the moisture content of the feedstock, for example, if you need to dry down the starting material. And yeah, I will say it really does vary. For farmers who are listening in now, that I know a number of farmers across New York State that are producing it at very small scales with kind of their annual, let's say, vine prunings or woody debris that gets built up, or when they're removing fields, like trees on clearing new fields, for example, and they'll produce just kind of biochar in a pit and mix it with the compost they produce on the farm or other compost they get. So they're kind of annually producing it in small batches, for example. So that's one way to really lower the cost and kind of manage the organic waste on your farm. But in terms of actually purchasing a pyrolysis kiln, for example, that can be very expensive depending upon your system, upwards of hundreds of thousands of dollars.
Great, thanks, Debbie. I had a question for you. Maybe this isn't as applicable in New York, where we're not doing as much irrigation as in Western states that are more drought heavy. But for example, if you're applying a lot of irrigation water that's high in salts, and you're also applying biochar, is there any chance that the biochar and the salts could get tied up together, or what is the interaction between salts in the soil and biochar?
Yeah, that's a really good question. It's actually something, because I haven't worked in irrigated systems or in desert, necessarily real desert environments with this. I haven't paid attention to it as much. But I know there has been some work in this area, so it's certainly something I could follow up on. I haven't seen any issues or interactions with salts in our area, kind of in the Northeast area, just because we don't have saline sodic soils, for example, and it hasn't been an issue. But it's certainly something that should be considered in certain environments where there are excessive buildup of salts. And also, even when we're irrigating, it's not necessarily as frequently like in Western states and things. But I will say, for any folks who are using herbicides, for example, there is tie-up of biochar with herbicides. And so they might inhibit the efficacy of some herbicide products. So it's important to think about the timing of biochar applications with any herbicide applications, or kind of where you're applying those, or in depth of the incorporation of the biochar as well. So there has been research in that area. So just from a weed control standpoint, it's something to be aware of.
Great, thank you so much. So we have a question here. Person from Maine is asking, they're trying to find out about the quality of biochar that spruce trees produce. Do you know anything about biochar from spruces?
No, not specifically. For that feedstock. There is a large biochar producer in Maine. Oh my God, I'm carbon something. And I'm not sure what feedstocks they are using. Spruce trees may be part of their the blend if they're using a mixed wood feedstock, which is often the case. I would say kind of a mixed woody feedstocks are the dominant biochar feedstocks in the Northeast, just because they are the most readily available kind of organic waste material. But this does vary, and it might vary locally, regionally, state by state a little bit as well. But I haven't heard anything specifically about spruce trees. So if the person can elaborate a little bit as to if there's a concern with it, or a little bit more as to why they might be interested in those specifically, that might help me think about it a little bit more.
Sounds good. Yeah, I will give that person my email, and if they'll shoot me an email, I can get some more info to them. Okay, so Simon is asking if there will be a recording. Yes, there will be a recording with this in the new commentary that'll be sent out in a week or two. I'll make sure that you get a hold of that. And then also, Debbie, do you have a copy of the original slides, and are you willing to share those?
Yes, I'm certainly happy to share these slides, and I'll also probably share with you, Savannah, a slightly an updated presentation from last month, or in from March actually, that I gave for American Farmland Trust that is updated really at least of the biochar slides, talking about web soil survey a little bit more, decision support tools, and actually thinking more on the 4 R's instead of the 3 R's for biochar application. So adding in the time factor, especially for those working at all with perennial fruit systems or perennial crops. I think the time factor is important. Has some updated pictures and figures, a lot of the same general information, at least from the biochar side of things, but just to have a little bit more up-to-date information, because the biochar world and the industry is growing and evolving rapidly. So some of the numbers around costs and other things are a little bit updated now. They've all changed from a year ago.
Great, understandable, yeah.
So I'll send both so people have it as a resource and can kind of compare.
Perfect. We'll make sure that gets sent out to everyone for your use. So there's a question here. Any thoughts on public sewage as feed source for biochar?
Yeah, good question, and certainly a hot topic right now. And actually before we started this today, I was mentioning to Savannah, we have a research trial looking at biosolids biochar. And I would say, I know this can be a very contentious topic. There's a lot happening around this space in the Hudson Valley right now, as folks might be aware of. I think we're still very much in the kind of case for caution stage around it, because of the PFAS and all the heavy metals and a lot of unknowns, let's say. So we're still very much in the research phase of thinking around our biosolid biochar safe for application. I think we know biosolids themselves, there's a lot of issues there, but there's a lot of evidence, at least initially, that the pyrolysis process mitigates or eliminates a lot of these PFAS and contaminants that are found in biosolids. So I'm actively involved in a research project in this area right now, but I wouldn't say we're at all ready to provide recommendations or guidelines around the use of biosolids biochar at any type of scale. So, right now, stick with clean sources of locally available, sustainably produced, so renewable feedstocks. Yeah, and I would say local is important too, or emphasize the local, because the transportation is a big cost for biochar, and obviously you're not offsetting your carbon credits if you're transporting carbon thousands of miles or around the country. So the local, sustainable, renewable feedstocks are really important. Often in the Northeast, like I mentioned before, these are woody materials. So right now I wouldn't go around applying biosolids biochar just because the research is not there to support large scale applications yet, but this is happening.
Great. Thank you so much, Debbie. We really do appreciate you. And I just want to put one last plug in. I put a link in the chat to registration for our biochar field day that Debbie's helping us put on in the Hudson Valley next month. We would love to have you all there. We really appreciate you being here today. And Debbie, thank you so much for being here to answer questions. If anyone needs anything, please send an email to me. My email is ss2655@cornell.edu. And thank you again so much for your time. Be on the lookout for the resources from this webinar. All right, everybody, have a good one. All right.
Thanks, bye.
Bye.